Well, we're very interested in having transformative education here at the university, and that generally happens when students are involved in their education in a deeper way.
I knew Dr. Mayer as my advisor, and I was talking to him about wanting to get into the lab and kind of see a different side of chemistry that I hadn't really gotten to experience before.
The whole idea is so that students can really get a very realistic picture of what graduate school will look like.
What we're working on right now is nanoparticle synthesis, and so we're trying to make these super tiny particles to certain specifications that we want.
This is cutting edge research. It's publishable.
It's a great experience. I don't think I would have gotten at a bigger school, and so that's one of the great things about being here. You get more personalized experience.
Getting our students into the lab and showing them how to take what they learn in the classroom and the laboratory classes and now apply that. That's something that we put a very high value on.
I work out at the ONPRC, the Oregon National Primate Research Center, extension of OHSU. The research we're doing is we're looking at the effects of the maternal diet, so the mom, what she eats when she's pregnant, and the effect of that on the offspring's brain.
We saw that the females were more anxious if their mothers were consuming a high-fat diet. The males were more aggressive and impairments in social behavior, so we really wanted to understand how the diet was causing these behavioral differences. And so Jeff came in to really help us understand why we're seeing changes in the brain and the mechanisms for those changes.
Do you guys know much about microglia first? A little bit? Okay, so it's like your immune system for your brain. They detect damage or infection, they'll change shape and become more amoeboid and turn activated. We're looking at the expression of these activated microglia and seeing if that would be a possible reason why we're seeing a reduction in serotonin synthesis.
Right now, as you can see with all the bugs buzzing around us, we have this green roof that started out with the sedum species that we have planted, but has been taken over by invasive grass species and really doesn't have a soil that's well draining. So it's very moist right now, which is why there's all the bugs flying around. I've been doing studies on 2 different soil types that 2 other students have developed. We call them after them, Brookeosol and Mykiosol. And these soils are designed to be better draining so that we don't get the moisture problem.
Our sedum species, which we've tested in our soils, have survived 2 summers now just fine. And that would have been a better choice for this green roof. It would be the right way to go moving forward.
My research shows that if we had green roofs designed with either the Brookeosol or Mykiosol soils that we have developed, we wouldn't have had hardly any rainwater runoff on the buildings that we have on campus. So just from that you can see applications in an urban setting with preventing stormwater flooding.